fast, degradable, and climate neutral. Algae as a new bioplastic? Many startups are researching one vision, using carbon dioxide from the air as a resource. Cyanobacteria, known as blue, and microalgae are a sign of its realization. However, the quantities still need to be more significant for industrial use, but this could change. Fossil resources produce PET, polyethylene terephthalate. Also, it has a short useful life. Polyethylene terephthalate is a thermoplastic from the polyester family produced by polycondensation. PET has a wide range of applications. We use it to make plastic bottles, PET bottles, films, and textile fibres, among other things. The European Union's ban on single-use plastic sometimes needs clarification. It is about its definition and is often circumvented. It is not only in the catering industry that plastic packaging is in use. Yet, there is also a need for more alternatives. The production of bioplastics does not need any fossil raw materials. Currently, manufacturers produce bioplastics using cornstarch. Yet, ethical questions are being discussed. For example, are raw materials used for food suitable for packaging material? Are the corresponding limited production areas ideal for packaging material? Specialized microalgae contain chlorophyll and are capable of photosynthesis. Of course, they intend to circumvent such questions. Cyanobacteria, blue or microalgae, can use sunlight energy to capture carbon dioxide. They convert it into sugar. Cultivating such algae does not need any agricultural land. Scientists are researching polyhydroxybutyrate production in cyanobacteria to optimize them for bioeconomic use. Heterotrophic bacteria, such as Cupriavidus necator, can already produce polyhydroxybutyrate bioplastic. These bacteria's energy source is the sugar obtained from crops. Cyanobacteria has a significant advantage in polyhydroxybutyrate production. To conclude, microalgae can fix sunlight and extract energy from it. As a result, polyhydroxybutyrate production is carbon dioxide neutral. Indeed, it offers ethical and ecological advantages over using heterotrophic bacteria. Polyhydroxybutyrate production by cyanobacteria is currently still in primary research mode. It could be years before it is ready for industrial utilization. Last but not least, there is also the question of price. Polyhydroxybutyrate production by heterotrophic bacteria is currently more cost-effective. Cyanobacteria, blue or microalgae, use light as an energy source. It is like algae, with their chlorophylls in photosynthesis. Besides, they are photoautotrophic bacteria. Oxygen is, thus, a product of photosynthesis. The oxygen produced by blue-green algae increases the oxygen content in the atmosphere. It enables the existence of living organisms. Cyanobacteria were among the first living organisms on this planet. Researchers have found fossil evidence in rocks in Australia and South Africa. They could be over 3 billion years old. It is important to remember that blue-green algae can multiply. Certain bodies of water at warm temperatures cause health problems in sensitive people. They even have a toxic effect on fish and other organisms in the water. Yet, people can use blue-green algae as a renewable raw material in various ways. Find examples in medicine and energy production for industrial purposes. In general, algae derivatives have several advantages over maize and other crops. They are more effective raw materials for the production of bioplastics. Productivity. Algae can produce biomass much faster than conventional crops such as maize. The plant can double its biomass in a few hours. So, plants such as maize need days or weeks for comparable growth. The rapid growth also favours productivity in small areas. Water requirements. Algae need less water than conventional crops, so we are making them easier to use in areas with limited water resources. Depending on their use, many algae also grow in salt water, which could reduce the need for fresh water. Fertilizer. Algae bind nitrogen from the atmosphere. This reduces the need for synthetic fertilizers. Carbon sequestration. Algae absorb carbon dioxide from the atmosphere during photosynthesis, helping to reduce greenhouse gas emissions. This makes algae a better option than conventional fossil fuel-based plastics. Wastewater. Research has shown that wastewater treatment could also use algae. This would contribute to reducing pollutants and be helpful. Algae are not yet the perfect solution for replacing plastic. Even so, the plants offer advantages over conventional crops such as maize. Energy and vitality thanks to algae and food sector. Algae can be valuable sources of nutrients for humans and animals. Algae are rich in carbohydrates but contain many proteins, vitamins and minerals. There are several thousand different types of algae. Sea vegetables is a well-known term for macroalgae. These can be used as a salad, vegetable garnish or spice. One of the most famous dishes made from nori algae is sushi. Nori leaves to wrap fish, vegetables and even rice. Microalgae such as spirulina and chlorella can also enrich the kitchen. One can use powdered microalgae in baking and mix it into shakes and smoothies. Yet, most people consume microalgae as food supplements, often in vegan capsules. Microalgae contain a wide range of bioactive vital substances. The levels of vitamin B12, folic acid, and utilizable iron are remarkable. They are also beneficial for the body's acid-base balance. The algae's high chlorophyll content increases the oxygen content in the blood. The coloring agent phycocyanin stimulates lymphocytes, giving it an immunizing effect. Give thanks to their protective substances. Microalgae have a considerable antioxidant effect on the organism.